Basically, in this video I would describe you how to solve radicals simply using algebraic methods. So we start with, well, what's radical? And basically if I had 2 square root 3, 3 is the radicand, and the 2 is on the outside. So basically that would be an example of a radical, or any square root of anything would be more so a radical. But the trick with radicals is not exactly as obvious as it should seem. Basically, if I had the square root of 64, we all know that equals 8, because 8 times 8 is 64, because 8 squared is 64. So if I had something else that was like, if I had the square root of 24, let's say, well, if I can't find that square root from two perfect ones, I need to learn how to simplify it. So what I'm going to do is I'm going to break this down. And I know that 6 and 4 make 24. So 4 times 6. So what I'm going to do is I'm going to, I know the square root of 4. Well, when I simplify, I have to take the highest square root I can find, the perfect square. And 4 happens to be there, so I'm going to take 4, and 4, the square root of 4 is 2, so it's going to be 2 equals 6. Okay, so that's our simplifying, because I'm moving this out over here, but I'm taking the square root of it and putting it there. But this will remain on the inside. So basically that's just simplifying, and once you learn simplifying, you can basically almost solve most radicals and any radical expression. But the key is also knowing your rules. If I add radicals like 2 radical 3 plus 5 radical 3. This does not mean I add radical 3's. This means I add the 2 and the 5, but they must have the common radical. If they do not, then you are to simplify, and then you should get a common radical, and if you don't, then you leave it simply as that. But over here, this would be 3. Okay, so that's all we basically do for addition, and even subtraction as well. Just when subtraction, when you simplify, be careful of the negative sign. But multiplication and division is rather different. If I had 2, 3 times 5 radical, let's say it's going to be 3 again. So what I have to do is I have to take what's on the outside and multiply it, and then what's on the inside and multiply it. So it'd be 2 times 5, which is 10, radical 9. But here 9 I know is a square root, so it'd be 3. Putting 3 over there, so it'd be 30. And that will be my answer. So when I have radicals that are being multiplied, I times the outside, and the inside by the inside. Same goes for division as well. The only thing to be wary of is rationalizing the denominator. Now, rationalizing the denominator just means you take the denominator, times it by the numerator and the denominator to make it more of a fraction and more easier to work with. So that's basically the straightforwardness of radicals, and you can always check in your calculator to see if you get the same answer as you did when you tried simplifying. But if I'm working with, like, let's say I had square root of x squared y squared, then what I'm going to do is, well, I take, since x times x equals x squared, put the x, so we're going to have x, and here y times y equals y squared. So square root is going to be xy. That's how it works if you have variables. And know your exponent properties such that you can understand that even powers you can divide by 2 and odd powers you cannot divide by 2. So you would have to break it down even further. Like if I had x to the 9, well, I know this cannot divide by 2. There's a power up here, so I'm going to do x8 times x. And I'm going to put this over here. It's going to be x4 square root x. Now that would be the answer to that. And that's about all we have to know about radicals. So if you have any questions, just ask. This is very straightforward.